So let's go ahead and start with an analogy for the sake of comparison. So suppose you're a bike manufacturer and you want to create bikes. The problem is you're running out of resources. You only have 3 bicycle frames left and you have 4 bicycle wheels. How many bikes can you make given these resources? Well, you have 3 frames, so I mean, in a perfect world, you would be able to make 3 bikes, but unfortunately, you only have 4 wheels, and because each bike needs 2 wheels, you can only make a total of 2 bicycles. Now, one of these reactants is the limiting reagent, and we call that, and the limiting reagent is also known as the limiting reactant. This right here, the wheels, is what we call the LR, or the limiting reactant, or reagent. Okay, and what's important is that the limiting reagent is what determines how much product you can make, right? It's the LR that determines how many bicycles you can make, not the reactant that you have excess of, okay? So here we're going to have 1 extra bicycle frame, but unfortunately we can't use that for anything. We can't use that bicycle frame to make any extra bikes because we don't have enough wheels. So that's the whole idea of limiting reactant. So we can use that to solve some problems. Okay, so rule number 1. There's a couple things to keep in mind. So the first one is use the number of moles of reactants to determine the limiting reagent. Very important, okay? You always use the number of moles, not the mass, not the number of grams. So if they give you grams, you have to convert to moles. So let's look at an example. So it says here, consider the following reaction. Hg plus Br2 makes HgBr2. They give us the molar masses of all of these guys. Usually you'll have to calculate this on the test. For the sake of convenience, I'm giving it to you here. They say, suppose that 10 grams of Hg reacts with 9 grams of Br2. Determine the limiting reagent, okay? So you might look at this at first and say, okay, I have 10 grams of mercury, and I only have 9 grams of bromine. Bromine must be a limiting reagent. You can't do that because you cannot look at number of grams. You have to convert to moles, okay? So that's one thing to keep in mind. The second thing is whenever they give you a whenever they give you a reaction, what you have to do is balance it or make sure that it's balanced. So in this case, it's already balanced, right? I have 1 Hg on the left, 1 on the right, 2 Brs on the left, and 2 Brs on the right. So here we don't really need to do anything, but you always need to check to make sure that the equation and the reaction is balanced. Otherwise, the rest of your calculations will be wrong. Okay, so let's start by converting these grams to moles, right? Using the molar masses. So we're going to start with 10.0 grams of Hg, right? And in order to convert to moles, we're going to use the molar mass, right? And my units on the bottom are going to have to cancel. So my grams of Hg is going to have to cancel with grams of Hg down here. So that's how you know which units to put down. And then you look at the mass. So this is going to be 200.59. And that will be per 1 mole of Hg. And then when we put this in our calculator and solve, we should get 0.0498 moles. Okay, so that's how many moles of Hg I have. And then I do the same thing for Br2. So I have 9.00 grams of Br2. And then I divide by the molar mass. And here the molar mass is given to you as 159.808 grams of Br2 per 1 mole. And then I solve for that, put it in my calculator, and I should get 0.0563 moles of Br2. All right? And now notice that in our balanced equation, all our stoichiometric coefficients are 1. So what this tells us is for every 1 mole of Hg, I should have 1 mole of Br2. All right, so it's a 1-to-1 ratio. Now, I have 0.0563 moles of Br2, but I only have 0.0498 moles of Hg. So what this tells us is that Hg is our limiting reagent. Right? So this is our LR. All right, so that's what's going to determine product yield. Okay, so that's the first part. So now we know which one is the limiting reagent. Let's move on to the second part of the question. And before we start, let's talk about rule number 2, right? So rule number 2 says, once you determine which reactant is the limiting reagent, which we just did, right? It's Hg, base the rest of your calculations on the limiting reagent, right? Specifically the number of moles you calculated, okay? So now they're asking us, same question, what mass of HgBr2 is formed? Okay, so that's the question. So what we're going to start with is the number of moles of the limiting reagent, which we just determined, which is 0.0498 moles of Hg. Okay, this is a 0 right here. Okay, so we want to essentially convert from units of Hg to units of HgBr2, because that's what we're looking for. This is what we're looking for. All right, and so in order to do that, in order to convert from one reagent or molecule to another, you need to use molar ratios. So here the molar ratios are all 1 to 1. So in order to convert from Hg to HgBr2, all I write is that for every 1 mole of Hg, I make how many moles of HgBr2? I make 2 of them. So in the top, I put 2 moles of HgBr2. And the reason I know to put moles of Hg on the bottom is so that they cancel with the units up here. All right? So now I have moles. Now my units are in terms of moles of HgBr2. But they're not asking for how many moles of HgBr2 are formed. They're asking for the mass. So the final step is to convert these moles of HgBr2 to grams. All right? And to do that, I use the molar mass. So for every 1 mole of HgBr2, I make, that's equal to 360.398 grams of HgBr2. And then I put everything in my calculator, right? I go ahead and do 0.0498 times 2 times 360.398, and that should get us 18.0 grams. All right? And I'm going to use 3 significant figures because that's what's given to me in the problem. So again, just a quick reminder to always base all your calculations from the limiting reagent, right? Because that's what determines product yields. Okay, so let's try the last part. So what if they ask you for the mass of the leftover reactant, which in this case is Br2? How do you do that? Well, all you have to use is use subtraction, right? Your starting number of moles of the excess reactant minus how much reacted with the LR, the limiting reagent, is how much is left over, all right? So if you remember from part A, we started with, when we converted from grams of Hg to moles and grams of Br2 to moles, we found that we had 0.0563 moles of Br2. So this is our excess reactant, the reactant that's going to have something left over. What we do is subtract by how many moles that react with the Hg, right? And the moles of Hg that we had was 0.0498. And so when we do this, we figure out how many moles of Br2 are left over. So when you calculate this, you should get 0.0065 moles of Br2, and that's how much is left over. So we'll call that excess, right? But they're not asking for a number of moles of Br2. They're asking for the mass, what mass of which reactant is left over, right? So we know it's Br2. Let's figure out what mass. All we have to do is convert from moles to grams, right? Which we've been doing all along. That's just dimensional analysis. So to convert from moles to grams, you use the molar mass, right? So for every 1 mole of Br2, that's equal to 159.808 grams of Br2. And then you put that in your calculator, solve, you should get 1.03 grams of Br2. Again, 3 sig figs because that's what we're given. So that's how you do a limiting reagent problem.